In the chapter of law of motion, we will do some multiple choice questions based on the pulley, spring and the string. First question is, mass of 1 kilogram is suspended by a thread, and in first case it is lifted up with an acceleration of 4.9 meter per second square, and in second case it is lowered with an acceleration of 4.9 meter per second square. We have to find the ratio of the tensions in these two cases. In first case, mass of 1 kilogram, which has the weight due to gravity given by 1g, where g is, we can take say 9.8 meter per second square, and it is suspended from a thread, and because of weight this thread has a tension T, and overall this body of 1 kilogram is moving upward with an acceleration of 4.9 meter per second square. So we can write the equation as T minus 1g, that is equal to mass into acceleration, that is 1 into 4.9. So T will be equal to, this is the first case, so it is T1, it is equal to 1g plus 4.9, or it is equal to 9.8 plus 4.9, or we can write it as 3 into 4.9. In second case, same body of 1 kilogram which has the weight 1g acting downward due to gravity, suspended from the thread which has tension here T2, and this mass is moving downward with an acceleration of 4.9 meter per second square. So we can write the equation of motion, that is 1g minus T2, that is equal to mass of the body, that is 1 kilogram, into acceleration, this is 4.9 meter per second square. So we can write T2 is equal to 1g minus 4.9, or it is 9.8 minus 4.9, or it is simply 4.9 Newton. Hence the ratio of the tensions T1 and T2 will be equal to 3 into 4.9 by 4.9, and it is equal to 3 by 1. Hence the option C is the correct option. Question number 2 is, two masses as shown in the figure are suspended from a massless pulley. This is the massless pulley, and these are suspended through a string, and because this is a single string connecting the masses 5g and 10g, so tension in this string will be same. If we represent the tension in the string, so this 5g will experience a tension T in upward direction, here this 10g will experience a tension T in the upward direction. This 5g is working downward because of gravity. Similarly, the weight 10g of the second body is acting in downward direction, and if this system of the masses is left free, then they start to move, and because 10g is heavier, so it moves with an acceleration A in downward direction. Similarly, this 5g will move in upward with the same acceleration A. So we can write the equations like for 10g, it is 10g minus T, this is the net force on the block of the 10g, and it is equal to, because mass is 10, into A. This is the equation number 1. Similarly, for other body, we can write T minus 5g, because 5g is moving upward, so tension T should be greater. So T minus 5g must equal to 5 into A. And now we add these two, because we need acceleration, so we have to eliminate the tension. Then we will get 5g, that is equal to 15A. So A will be equal to 5g by 15, and it is equal to g by 3. Hence the option B is the correct option. Third question is, two blocks A and B of the masses 3m and m respectively are connected by a massless and the inextensible string. It implies that tension is same throughout its length. The whole system is suspended by a massless spring as shown in the figure. The magnitude of the acceleration of the A and B immediately after the string is cut are respectively. Here, the tension in the string will be T. So, in condition when string is not cut, in that case, the free body diagram of the B will say that weight mg is acting downward and tension is in upward direction, and this T balances mg and block B remains in the balance condition. Similarly, if we draw the free body diagram of body A, its weight 3 mg will work downward due to gravity, tension is shown downward, and the spring force due to the spring will be upward, and this spring force will balance 3 mg plus T. And because T is mg, so we can write it as 3 mg plus mg, that is 4 mg. That means a spring will provide the 4 mg force to balance the downward forces and make the body A at rest. Now string is cut. If string is cut, in that case T will become 0. If tension becomes 0, so from the diagram of the body B, the net force mg, which is acting downward, so acceleration will be ma equal to mg or A equal to g. Now for body A, the net force which act on the body A, that will be equal to spring force, which is 4 mg, minus the weight which is acting in opposite direction, that is 3 mg. So net force will be equal to mg, and this force will result the acceleration in the body A, which has the mass 3m. So we can write 3m into A equal to mg. So acceleration in the body A will be equal to g by 3. Hence, for the question, correct options are g by 3 and g, that is A. Fourth question is, relate the acceleration of the block A and block B. They are the two blocks A and B which are connected by a string. L0 is the length of a string, and this block A is pulled by a force F, and we have to find the relation in the acceleration. To get the relation, we have to first write a constraint obeyed by the system. The constraint is that length of the string is constant. So first we find the distances of the blocks from the fixed side, which is this left hand side. This is the fixed side. From the fixed side, the distance of the block is xb. xb is the distance of block B from fixed end. Similarly, distance of the block A is xa from the fixed side. Therefore, in terms of the xa and xb, we can write xa equal to xb plus L0. This is the xa, which is equal to x0 plus L0, xa plus L0. So on differentiating with respect to time, we will have dxa by dt, that is equal to dxb by dt plus 0, because L0 is a constant. We have already given that L0 is the length of the string, it is not changing. Only xa and xb will change as the block A and B moves. This implies that VA will be equal to VB. This is our first equation. Further differentiating with respect to time, we will have dVA by dt is equal to dVB by dt, and this further be written as, because rate of change of velocity is acceleration, we can write acceleration of A equal to acceleration of B. This is our second equation. So answer is, the acceleration of the A and B will be same because the distance between them is fixed, which is equal to the length of the string.